Yeah, so let's first talk about front deletion. First, I'm considering 3 nodes 10, 20, and 30. I've taken my self-referential structure as shown above in the right corner. I'm taking a pointer head pointing to the first node, and also I'm taking another pointer temp pointing to the first node initially. This temp pointer is required because when we are deleting the first node, we move head to the next node, which will be the first node in the new list. And when we do so, we lose reference to the first node. Hence, I'm using this another pointer temp. Now, let's write the logic. I'm first assigning the value of head to temp, and then I'm moving head to the next node using head equal to head of right. Then I have to free the memory of the temp node. So I'm doing so using function free temp. Now we know that in a double linked list, the left link of the first node and the right link of the last node must be pointing to null. So after deleting the first node, I have to assign null to the left link of the head. So I'm doing so using head of left is equal to null. And this is the full code. Here I'm including another condition where there are no nodes in the list. In such a case, we cannot delete any node. So I'm displaying list is empty, else I'm doing the rest other part. And these are the steps that can be followed. And yeah, this is all about front deletion. Now coming to the rear deletion, I'm again taking 3 nodes 40, 50 and 60. First node is head node. Now we have to delete the last node. So I'm using temp pointer for traversing through the list to reach the last node. I'm using this while loop. Let's just do the dry run for this. First we check for the condition. Temp of right not equal to null. It is true. So we enter the loop. Now I'm assigning the value of temp to prev, and this prev pointer is required again so that we do not lose reference to the previous node while deleting the last node. And then we move temp to the next node using temp equal to temp of right, and then we exit the loop, and again we check for the condition. Yeah, it is true second time also, so we enter the loop, and prev and temp are moved to the next nodes, and then we exit the loop. As of now, 2 iterations are completed. Now when we are entering the loop for the third time, we check for the condition, but here temp of right is equal to null, so it does not enter the loop. Yeah, on reaching the last node, we delete the node and we assign null to the right link of the previous node. So, and this is how our final list looks like, and this is the code. Here I'm including another 2 conditions. First condition is where there are no nodes in the list, that is head equal to null, so I'm displaying list is empty. And the other condition is where there is only one node in the list, so I directly delete the node. There is no need of assigning another pointer, that is prev. And the third condition is which we have just discussed, and these are the steps that can be followed. And yeah, this is all about rear deletion.
Yeah, so coming to random deletion, here again I'm considering 5 nodes. We're given a search element to be deleted, that is 72. So we have to delete this node and create a link between the previous node and the next node. For this we are using 2 pointers, that is prev and next. Now to reach the search element, I'm using this while loop. So first here, the first condition is to traverse through the list until the last node, and the second condition is to stop traversing while we have reached the search element. On entering the loop for the first iteration, we assign the value of temp to prev, and then we shift the temp to the next node using temp equal to temp of right, and then we assign the value of temp of right to next, and then we exit the loop. And for the second iteration, the same thing happens because both the conditions are true, and the pointers prev, temp and next are shifted to the next nodes. And again third iteration happens. But for the fourth iteration, we check for the conditions. The first condition, temp of right not equal to null, is true, but the second condition, temp of val not equal to key, is not true because we've already reached the search element. So our iteration stops here, and we have reached the search element. So then we delete the value of temp. Before that, we have to establish a link between the previous node and the next node. So we do that using prev of right equal to next and next of left equal to temp of left. So our link is established, and then we delete the temp, and yeah, this is how the final list looks like. And this is the code, and these are the steps that can be followed. And yeah, this is about random deletion. So we have discussed friend deletion, rare deletion, and random deletion, and this is all about deletion in double linked lists.